Alright folks, so welcome to yet another exciting session of co-prime statistics. My name is Isaac Kofi Ej, and this is the session for quantitative methods in social research lecture 1. As I always say, if you've not subscribed to our YouTube channel, kindly do well to subscribe, and do not forget to hit on the bell icon so that you don't miss any updates from co-prime statistics. Also do well to like and share our videos as well. So for our outline, we are going to look at the definition and scope of statistics, and then we'll look at the types of variables, and then population versus samples. Okay, so these are the three important things that we are going to consider in this lecture. Now let's look at the definition for statistics. Statistics consist of conducting studies to collect, organize, summarize, and analyze data, and finally draw conclusion about that data. Okay, so the main aim of statistics is to collect data, organize that data, make a summary out of that data, analyze that data, and finally draw conclusion about data. Okay, so you realize that the scope or definition of statistics is a scientific way of using data to actually solve problems. Okay, so now let's look at the definition for data. Right, they are the values or measurements or observations that the variables can assume. As simple as that. Okay, so now let's take note of this. Variables whose values are obtained by chance are called random variables. This means that variables whose values are not obtained by chance are not random. As simple as that. So variables whose values are obtained by chance are called random variables, and those variables whose values are not obtained by chance are not random. Okay, and also note that a collection of data values or points forms a data set. So looking at the example given below, 4.8 becomes a data value, okay, whilst the whole table becomes a data set. Okay, so it means that if I pick any of the points in this table, I can pick 4.7, 4.6, 5.3, 4.9. Any of these points becomes a data value, but if I combine all of them together, then I have a data set. Now let's look at the definition for let's look at the types of variables. Okay, so we are going to differentiate between the types of variables. So there are two types of variables to be considered. We have qualitative variables and quantitative variables. So for qualitative variables, the characteristics under study or observation is not measurable. This means that they cannot take numeric values, hence they are non-numeric. Okay, so they cannot take values like 4, 5.5, 7, 8.4, or 9.2. Okay, so they can't take any numeric value. All right, an example is your country of residence, political affiliation, gender, color, and religion. So you realize that at no point in time will I ask you of your country of residence and you tell me it's 4.8 or 2.3. You can either tell me you are Ghanaian, or you are from Togo, or you are probably from Zimbabwe. Okay, so it means that with qualitative variables, they cannot assume numeric values, meaning that the best we can do to them is either rank or probably group them. Okay, so now let's look at the counterpart of qualitative variable, which is quantitative variables. So for quantitative variables, data obtained can be measured or can obtain numeric values. Okay, so unlike qualitative variables, quantitative variables can assume numeric values. So an example is your income, age, distance, temperature, and examination score. Okay, so I can say my income is 300 cedis, or I am 19 years old, or probably Kofi covered a distance of 25 kilometers. Right, all these are numeric values, making them example of quantitative variables. Okay, so note that unlike qualitative variables, quantitative variables can pick or assume numeric form. Okay. So now let's look at the difference between discrete variables and continuous variables. So remember that before a variable can be classified as either discrete or continuous, then it means that variable is quantitative. This means that qualitative variables cannot be classified as either discrete or continuous. Okay. So quantitative variables can be classified as either discrete or continuous, whilst qualitative variables cannot. This is because qualitative variables cannot take numeric form, hence they can be classified as either discrete or continuous. Okay. So now discrete variables, they can only take finite values, and I repeat, finite values like 4, 2, 5, or probably 20 or 19. Okay. So an example is the number of siblings, number of horses in the stable, or number of patients in an ICU. All right. So if I ask you of the number of patients in an ICU, you can't tell me there are 4.8 number of patients in an ICU. You have to give me a finite answer. So, probably there are 19 people in the ICU. Or how many siblings do you have? You can't tell me you have 2.8 siblings. Okay, that would be ridiculous. But you can have probably 4 siblings or 2 siblings. That is finite. So that makes such an example discrete. Okay. Now let's look at the counterpart of this, which is continuous variables. So for continuous variables, they can obtain their numeric values that have an infinite number of values between any two values. So this means that there are no breaks. Okay. Example is time, weight, height, and temperature. So taking height as an example, someone can have a height of 5.6, a height of 6.2. Okay, so it means that unlike discrete variables, continuous variables can take decimal points. Okay, so it can be 4.2, 5.8. This means that if you pick any two numeric values, so let's pick 3 and 5. Just between 3 and 5, there exist several numbers such as 3.8, 3.02, 3.58, 3.12. There are so many values just between the 3 and 5. Okay. But for discrete variables, if I pick 3 and 5, the only number between 3 and 5 is 4. Okay. So as simple as that. Now let's consider the difference between a population and a sample. Okay. So it's very, very important in statistics to actually difference between what we mean by population and then a sample. Okay. So for a population, it is the totality of any collection of items. All right. So an example is a population of level 100 students, population of medical doctors, etc. Right. So oftentimes when we talk about population, a lot of people's attention is drawn to human beings. But note that population doesn't necessarily talk about only human being, but the collection or the totality of anything is termed as a population, okay, in statistics. All right. So now note that information obtained from a population are called population parameters. Okay, so any information we obtain from a population, they are called population parameters. Now let's look at the definition for sample. This is a subset of a population. Okay, so note that information obtained from a sample are called sample statistics. So while information from a population are called parameters, that of sample are called sample statistics. Now note that there is a reason why we sample. So we sample because of cost, we sample because of limited resources, and we sample probably because of time constraints. Okay. So sometimes it becomes impossible or very difficult to actually look at the whole population in general, especially when the population is very huge. So what we do is that we sample from that population. What we are going to do is that we are going to take a subset of that population. So a sample becomes a subset of a population. Okay. And then when we take a sample, we make sure that that sample represents or resembles the population as close as possible. Okay. So because of cost and time constraints, we may not be able to look at the whole population in general. So what we do is that we sample items from that population, units from that population, and then we use it to generalize about the whole population. So if I want to talk about the average height of medical doctors in Ghana, I cannot measure the height of all medical doctors in Ghana, but probably I may sample some doctors from Ghana. So probably some from Okonfanochi Teaching Hospital, some from Kolebu Teaching Hospital, and other hospitals. Right. Then what I do is that out of the samples that I've taken, I'm going to measure their height, and then the height that I'm going to get from this sample, I'm going to use it to generalize about the whole medical doctors in Ghana. Okay. Now let's also look at the difference between descriptive and inferential statistics. Okay. So for descriptive statistics, we are using data gathered on a particular group to describe or reach conclusions about that same group. So we collect information about a particular group, and after getting that information, what we do is that we are going to use that information generalize about only that group. Okay, so groups outside this group considered, let me put it that way. Okay, so the information collected is for only that group, or the conclusion we are going to make is just about that group. Okay, but unlike inferential statistics, we are using sample data to make conclusion about the population from which that data was taken from. So as I made mention of, we pick a sample and we make sure that that sample represents the population as close as possible, so that any information we get from that sample, we can use it to generalize the whole population. So this is what we call, or we term, inferential statistics, using sample data to make conclusion about the whole population. Okay. So in summary, today we've learned the definition and scope of statistics. We've learned to differentiate between variables, qualitative and quantitative. We've also seen the difference between population and then sample. And then finally, we look at descriptive and inferential statistics. I hope this lecture was helpful. Subscribe to our YouTube channel. Kindly do all to subscribe and press on the bell icon so that you never miss any updates from Co Prime Statistics. Thank you very much.